Hello everyone, this is Arush Swami. Welcome back to our channel ATS Info. Please do subscribe and like. This video will be interesting. As you know, we'll learn the basics and some advanced topics about the plane. So let's get started. The lift is generated by each part of the plane, but mostly by the wings. Lift is a mechanical aerodynamic force produced by the motion of the plane through air. Lifts acts through the center pressure of the object and is directed perpendicular to the flow direction. Now the plane has three main or primary controls: airlines, stabilizer or elevator, and the rudder. Ailerons are mounted on the trailing edge of each wing near the wingtips and move in opposite directions. When the pilot moves the joystick towards the left aileron goes up and right aileron goes down. It happens opposite when the pilot moves it towards the right. A raised aileron reduces lift on that wing and a lowered one increases it, so moving the joystick towards left causes left to drop and right to rise. This causes the aircraft to roll towards left and begin to turn to the left. Now second elevator. The elevator is a movable part of the horizontal stabilizer hinged to the back of the fixed parts of the horizontal tail. The elevator moves up and down together when the pilot pulls the joystick backwards. The elevators go up. Pushing the stick forward causes the elevators to go down. Raised elevators push the tail down, causing the nose to rise. This makes the wings fly higher angle of attack, which generates more lift and more drag. Now what is angle of attack? Angle of attack is the angle at which the moving air comes in contact with the wings. Now the last rudder, guys. If you are getting bored, please bear with us, as this knowledge will help you in our future videos, which will be extremely interesting. So let's continue. Rudder is typically mounted on the trailing edge of the vertical stabilizer part of the empennage. When the pilot pushes the left pedal, the rudder deflects left. Deflecting the rudder left causes the tail to go right and the nose to yaw to the right. So now I would request aviation enthusiast Tilak Mistry to continue and tell us about the APU, the RAT, the hydraulics. Tilak, please continue.
Thank you very much, Arush. So let's continue. An APU or auxiliary power unit allows plane to operate autonomously without reliance on ground support equipment such as ground power unit, that is GPU, an external air conditioning unit, or a high pressure air start car. The APU is a small jet engine which is normally located in the tail cone of the plane, but in some cases it is located in an engine nacelle or in wheel wall. The APU can be started utilizing only the plane batteries, and once running will provide electric power to aircraft systems as well as bleed air for the air conditioning and engine start. When APU is certified for use in flight, the APU can be used as required to provide additional source of electric power in the event of loss of engine generator, and it can also be used as a source of bleed air for starter assist for an in-flight relight or off power. The air conditioning packs in the event conditions or company policy dictate that the takeoff will be conducted with the engine bleed turned off. Now let's go to the second part, RAT, that is ram air turbine. Modern planes generally use RATs, that is RATs, only in emergency. In case of loss of both primary and auxiliary power sources, the RAT will power vital systems like flight controls linked with hydraulics and also critical in-flight instruments. Some RATs produce only hydraulic power, which is in turn used to produce electric generators. In some early aircrafts, even airships, small RATs were permanently mounted and operated a small electrical generator or fuel pump. Some constant speed propellers, such as those of Argus AS 410 engines, used the Focke-Wulf FW 189, used a propeller turbine on the spinner to power a self-controlled pitch governor controlling the constant airspeed. RATs generate power from airstream due to the speed of the aircraft. If aircraft speeds are low, the RAT will produce less power. In normal conditions, the RAT is retracted from the fuselage, that is the body or the wing, and is deployed manually or automatically following complete loss of power. Now, hydraulic systems are used on an aircraft to move and acute landing gear. Flaps, brakes. Larger aircrafts use these systems also on flight controls, spoilers, thrust reversers, and whatnot. The reason to use hydraulics is because they are able to transmit very high pressure of force with small volume of hydraulic oil. Power assisted brakes, one application where you will see hydraulics the most in small experimental is and ultralight aircraft. They are very reliable. It is fluid, is virtually incompressible and able to transmit high pressure, but it's not lightweight compared to the mnemonic systems. Usually, aircraft builders will put their aircraft brake systems themselves, so it is helpful to gain the understanding of how hydraulics work and how to handle it safely during installation of maintenance. Now I would request Sushant to continue.
Thank you very much, Tilak. So let's continue. Now there are 4 secondary axes: spoilers, flaps, slats, and air brakes. So let's start with the spoilers. On low-drag aircraft such as seaplanes, spoilers are used to disrupt airflow over the wing and greatly reduce lift. This allows a glider pilot to lose altitude without gaining excessive airspeed. Spoilers are sometimes called lift dumpers. Lift dumpers. Spoilers that can be used asymmetrically are called spoilerons and can affect an aircraft's roll. Now, this was about spoilers. Let's go to flaps. Flaps are mounted on the trailing edge on the inner board section of each wing near the wing roots. They are deflected down to increase the effective curvature of the wing. Flap raise the maximum lift coefficient of the aircraft and therefore reducing the stall speed. Now, what is stall? Stall speed is lowest speed at which the plane can fly. Now back to flaps. They are used during low speed, high angle of attack flight including takeoff and descent for landing. Some flights have innerboard flaperons and are called innerboard ailerons. This device function primarily as ailerons, but on some aircraft will drop when the flaps are deployed, thus acting as both a flap and a roll control innerboard aileron. Now to slats. Slats are also known as leading edge devices, are extensions to the front of wing for life augmentation and are intended to reduce the stalling speed by altering the airflow over the wing. Slats may be fixed or retractable. Fixed slats give excellent yaw speed and stall capabilities. but compromise higher speed performance. Retractable slats are seen in most airlines, provided reducing stalling speed for takeoff and landing, but are retracted for cruising. Now, finally, air brakes. Air brakes are used to increase drag. Spoilers might act air brakes, but are not pure brakes, as they function as lift dampers or in some cases as roll control surfaces. Air brakes are used surfaces that deflect outwards from the fuselage, in most cases symmetrically on the opposite sides into the airstream, in order to increase form of drag, as they are in most cases located elsewhere on the aircraft, so they do not directly affect the lift generated to the wing. Their purpose is to slow the plane. They are particularly used when a high rate of descent is required. They are common in military aircraft and small civil aircraft as well. So that is all for today. Guys, please comment the question. We are here to solve your question. And I have been seeing that most of the people watch the video but don't subscribe. So please subscribe, guys. Please. Aviation is the future. Aviation will be everything. This channel is dedicated to make aviation safer. Also, please do subscribe so I'm start gaming. Please guys, please subscribe out our channel.